Welcome, dear students. Today we discuss about 2024 question paper SEC-3 for B.Sc Honors in Chemistry, Semester 3 under CCF, Numerical in Chemistry. This is the question paper 2024 Introduction to Numerical Methods in Chemistry. First question, convert the following binary number into base 10. This is the number 0.000301113 ones, the binary form. It is clear that after binary point on the right hand side, this 0 into 2 to the power minus 1, and this 0 into 2 to the power minus 2, this 0 into 2 to the power minus 3, this 1 2 to the power minus 4, and this, and hence the result is this. Question 1b, what is IEEE 754 single precision floating point representation of 0.7425 to the base 10? Already we have discussed this question in a previous video, so we avoid detailed discussion here. And this is the first we convert this decimal to binary, and next normalize the binary number and calculate the biased exponent, and converts the biased exponent this to binary form. Next, identify the mantissa, and this is the final form, and this is the link this IEEE Institute of Electrical and Electronics Engineers for the conversion for this floating point representation. Next question 1c, set a suitable transcendental equation to solve fx equal to x cube plus x minus 1 equal to 0 by method of iteration, fixed point iteration with a guess x equal to 1. Here, fixed point iteration method, the equation fx equal to 0 must be rearranged into equivalent form x equal to gx. First, we express fx equal to this in this form x equal to gx, such that the condition for convergence, that is the modulus of g dash x is less than 1, is satisfied in an interval around the root. Here the initial root x equal to 1. So fx equals to, we first this fx equals to this x cube plus x minus 1 equal to 0. A root lies in the non-interval 0 to 1. We rearrange it into a suitable form. So this equal to this implies x cube plus x plus equal to 1. This equal to x equal to 1 by x square plus 1. This is the very difficult step to rearrange this term x equal to some function gx, so that the condition of convergence modulus of g dash x is less than 1. It is very much difficult to identify this x equal to some function gx, and this gives the iteration function gx equal to 1 by x square plus 1, and this x equal to gx, this is the gx, leading to the iterative formula, this xn plus 1 equal to 1 by xn square plus 1 n equal to 0, 1, 2 and so on up to desired level of accuracy. Now f0 dot f1 equal to minus 1 into 1. If we put f0, so we get this equal to 0 plus 0 minus 1. So this equal to minus 1. And if we put f equal to 1, x equal to 1 in fx, so we get 1. So f0 into f1 equal to negative minus 1. So a real root of this equation fx equal to 0 must lie within the interval 0 to 1. The condition convergence, this modulus of g dash x is less than 1 near the root. So we find first g dash x. G dash x means this 1 by x square plus 1. So derivative of this ddx, this minus 2x divided by x square plus 1 whole square. Next, the initial case x0 equal to 1. So we find the modulus of g dash 1, this equal to 0.5, which is less than 1. So the iteration using this formula will converge with the initial guess x0 equal to 1. And this is the question is this, set a suitable tensorial equation to solve this. So we have shown this. This is the suitable function x equal to gx, this equal to x equal to 1 by x square plus 1, and which satisfy the condition of convergence, this modulus of g dash x equal to less than 1. And this is the question. Next question, 1D. What is the difference between interpolation and extrapolation? Actually, interpolation is the process of estimating a value that falls within the range of our estimating data points. Interpolation is generally highly reliable and accurate because it relies on established trend boundary by actual observation on both sides. Whereas extrapolation is the process of estimating a value that falls outside the range of our existing data points. Extrapolation involves a higher degree of uncertainty and risks of error. It assumes that the trends observed within the data range continue in the same manner outside of it, which may not be true. With this whiteboard, on this whiteboard, uh, let us observe that this x and this is the fx. So this x equals to say 1, this fx equal to say 2.5, this x equal to 2, this equals to say 7.5, and this 3, and this fx equals to say 9.2, and so on. Now, if you find, but analytical form of fx, you do not know of the analytical form of fx. So you have to find this. This is the given data. This is the given data. So if you have to find this for x equals to 2.5. So what is the fx for this 2.5? Then this is the interpolation, because interpolation means the for this x 2.5 we want to find the value of fx, and this 2.5, this x lies within the given data. So this is the interpolation. But when x lies outside the data, say this say 3.5, this is the outside of this data points, this. So this three, we want to find the value of fx for this 3.5. So this is the extrapolation. This is the extrapolation. Next, next question 1e, what is linear correlation coefficient R? What are the properties of R? Linear correlation coefficient, often denoted by R and sometimes referred to as Pearson's correlation coefficient, is a statistical measure that quantifies the strength and direction of the linear relationship between the two quantitative variables, usually denoted as x and y. This R equal to formula covariance of x and y and Sx Sy. This covariance between x and y and Sx and Sy are their respective standard deviation. This is the formula. This say x is the height of a student, and this is the x, y is the variable corresponds to weight of a student. So for rule number 1, this x is height, see x1, this weight, y1 data. So rule number 2 is x2 for height and y2 is the weight, and we want to correlate this weight and height and weight between this, and this is the formula. And this, the value for of R has no units of measurement. This is the ratio, no unit of measurement. It is a standardized value calculated from the data. The value of R always lies within the -1 and +1, including -1 and +1. The coefficient of correlation coefficient is invariant to linear transformation, changes the scale or location. So it is invariant for linear transformation, that is the for changes in scale or location. And number 4, the sign of R determines the direction of the relationship. If R is positive, there is a positive linear correlation. As variable x increases, variable y tends to increase. If R is negative, there is a negative linear correlation. Variable x increases, variable y tends to decrease. But this value of R equal to 0 does not necessarily mean that there is no relationship at all. Only that there is no straight line linear shape. The data might follow a strong curved nonlinear pattern. If two variables x and y are truly statistically independent, then their correlation coefficient R must be 0. But R equal to 0 does not necessarily imply the independence of two variables. Very important is the correlation between x and y is same as the correlation between y and x. So Rxy equal to Ryx. Next question 1f. For a function fx equal to x cube plus x minus 1, find the derivative at x equal to 1 with h equal to 0.1 using central difference method. The formula is this: the central difference method f dash x, this is approximately equal to f of x plus h minus f of x minus h whole divided by twice h. Here fx equals to this function at the point x equal to 1, and stable length is given by h equal to 0.1. So f dash 1 is approximately equal to f of 1 plus 0.1 minus f of 1 minus 0.1 whole divided by 2 into h 0.1, and after calculation we get 4.01. This is the central difference formula to find the derivative. Next question 1g. Why central difference method for numerical differentiation is considered to be better method than forward and backward difference method? Because central difference method is considered superior to the forward and backward difference methods because it provides the significantly higher accuracy for the same step size h. In the forward backward difference, the order of accuracy is of first order, and this the error, and actually this figure is for Simpson one-third rule. The error is proportional to the step size h. In the central difference, the order of accuracy is of second order, that is the order of h square. The error is proportional to the square of the step size h square. Central method uses x minus h and x plus h. By averaging the rate of change across this symmetric interval, the inherent biases, that is errors, of the forward and backward methods largely cancel out each other. This symmetry allows the central difference method to effectively remove the largest source of error in the approximation, resulting in much more accurate estimate of the derivative. Next question. State why Simpson's rule is often called parabolic rule. Simpson rule is often called the parabolic rule because we approximate the area of the under the curve. Actually, Simpson's rule, we integrate a function a to b fx dx, a to b fx dx. This I want to integrate this. This is the fx, this is the a, this is the b, this is the x-axis, horizontal axis, the vertical axis, y-axis, and this is the blue curve is the fx. So, want to find integration a to b fx dx means the area under this x equal to a, x equal to b, and the x-axis, and under the curve y equal to fx. And this by fitting parabola px, second degree polynomial. Actually, this is the px, this is the red curve, second degree polynomial px. this to segment of the function fx rather than the straight line. This is the first degree polynomial. So this is the polynomial, second degree polynomial, this curve, and this uh, we take three adjacent point, two intervals at a time. So it is for two intervals, even number of intervals, the Simpson's one-third rule, and it then feeds a unique parabola px through these 3 points and calculate the area exactly under the curved segment. This is a second degree parabola, that is ax square plus bx plus c. This is the px. This is the approximate parabolas approximate to the exact curve fx. Next one, I write down the midpoint rule for numerical integration. The midpoint rule is method of approximating a definite integral by dividing the area under the curve into a series of rectangles using the function value at the midpoint of each interval to determine the height of that rectangle. To approximate the integral of fx from a to b using n equal to 4 intervals, the formula expanded this list. So we want to find this integration a to b fx dx. So this function fx is, now we subdivide this subinterval, this x0 to x1, x1 to x2, x2 to x3, and x3 to x4. This is the subintervals, 4 subintervals. Next we find the midpoint of each subinterval. This m1 is the midpoint of the subinterval x0 x1, m2 is the midpoint of the subinterval x1 x2, and m3 is the midpoint of the subinterval, and this. Next we find this corresponding and the value of fx at this midpoint. So this midpoint means x0 plus x1 by 2. This m1 equal to x0 plus x1 by 2, and value of f at this point m1, and this is the corresponding height. This is the f of x0 plus x1 by 2. So this is the height, and this height plus this is the area. Area means b minus a by 4. Actually b minus a by 4 is the corresponding step length h. This is the b minus a by 4. This is the 4 subintervals. So actually this h into f of m1 and gives the area of this rectangle. H into f of x1 plus x2 by 2, that is actually m2, f of m2. This is the height of this, this is the area of this rectangle. So we sum of this area of these rectangles, and this is this. Obviously clear that this is the error, this is the error, and this the white color in error under the integration a to b fx dx, and this is the midpoint rule. Next 1J, explain the forward Euler's method. The forward Euler's method, also called the simple Euler method, is a basic and widely used numerical procedure for solving initial value problem IVP in the ordinary differential equation ODE. It is the first order method. So this is the first order linear differential equation dy dx ddx of y equal to f of xy, f of xy, and subject to the initial condition this y at the point x0, this is equal to y0, and this is the initial value method. We want to find the solve this by this Euler method, forward Euler method. This method uses a constant step length h, this xn plus 1 minus xn. The iterative formula, this is the yn plus 1 equal to yn plus h into f of xn yn, and this is the formula for Euler method after simplifying this fxy by expanding by Taylor series and so on. The smaller step size h, the better approximation generally becomes, but the more calculation are required. And this is the Euler's method, and this is the geometrical interpretation of the Euler's method. Actually, this is the curve. This is the curve. This curve. This I want to find the curve. We want to find the curve. This curve is not fxy. This curve is not fxy. This curve is not actually this fxy represents the derivative of this curve at any point within this interval fxy. So this is the x0 is the initial point on the x-axis, and corresponding this y0 it is given by initial condition this. Next, and this is the step length h. So this is the uh, right angle triangle, this right angle triangle, this right angle triangle, this perpendicular by base, this is equal to tan theta. This tan theta is equal to dy dx. This is equal to actually a f of x0 y0. This f x0 gives the slope of the curve. This is the curve at this point. So if we draw a tangent on the curve, this curve is unknown. This curve is unknown. So curve at the point x0, y0, then this angle theta with the positive x-axis in anticlockwise sense, this theta, tan theta, at this tan theta, this angle theta. So this tan theta gives this value of f of x0, y0. Then, and this is the height from this right angle triangle, this height by base, this is equal to tan theta. So obviously this height equal to h into this tan theta, h into tan theta. So this by this equal to tan theta. So this height equal to h into f. So this h in this height is h f of x0 y0, and this height is y0. So y0 plus h f of x0 y0. This point gives the calculated value of y for the x1, but the exact value is this point on this curve. The curve is unknown here, and this is the uh, next we draw a tangent at this point to the curve. This actually this tangent, if we draw this tangent at this point x1 y1, this tangent is parallel to the tangent on the exact point on this. Next 1k, write down the general expression for the Fourier series. The Fourier series periodic function fx with period t equal to twice L defined over an interval, example minus L to L or 0 to twice L. And so the general expression for its Fourier series, this fx equals to a0 plus in summation n equal to 1 to infinity bracket n cos of n pi x by L plus bn sine n by x by L. This is the general form. The integration limits can be changed by any single interval of length twice L, such as minus pi to pi, say 0 to 2 pi, and so on. This periodic interval of this. Next question, this for the function of xy with periodicity p equal to twice L, write down the Fourier series along with the Euler's formula for the coefficient. So next question, 1L actually gives the value of a0, an, and bn, and a0 is equal to 1 by twice L integration minus L to L fx dx, and an is the 1 by L integration minus L to L fx cos of n pi x by L for n equal to 1 to 3, and bn equal to 1 by L integration minus L to L fx sine of n pi x by L dx for n equal to 1 to 3. Thank you for this question 1, this short question for this 2 into 10. This is the short type question. Question marks is 2.